In this video, we're going to discuss equation 48. Equation 46 is similar to equation 48. They will solve the same variable, much like 47 and 46. In the solutions that I have posted, I have used equation 45 and 46. But for our purposes in these videos, I'm going to use equation 47 and 48. Looking at equation 48, here it is. A represents activity. Activity is defined as such. And remember the word rate that I said back in class many times, something divided by time. A represents the activity left after decay. Amount that is left over after a period of time. The unit for activity is the becquerel, BQ, named after Henry Becquerel. And the becquerel is the SI, or the metric unit for radioactivity. One becquerel is equal to 1 decay per second. There is another unit that is used for activity. And that is the Curie. The Curie. And it has the letters CI. The Curie. 1 Curie is equal to 3.7 times 10 to the power of 10 decays per second. There is a relationship between these two, and here it is. And when we're talking 1 decay per second, it means that the nucleus of the atom is emitting out a particle, an alpha, beta, or gamma particle. And if you recall here, half-lives, and here are the various particles, the decay modes. It's either going to emit out an alpha, beta, or gamma, depending on the species. By species, I mean the radioactive elements. And each one has its own half-life. So the emission of one of these particles is a becquerel, 1 decay per second. Going back to our equation, A naught. This is the initial decay, and it's pronounced A naught. A naught is the Old English word for 0. We have A sub 0, and it's pronounced A naught. Sometimes I write it A naught. And A naught is the initial activity. What we start with, and over a period of time, this is what we are left with. E, the exponential constant. I talked about this in a previous video. And comes lambda. That is the decay constant. And it is in terms of time, in seconds, minutes, hours. Again, I spoke about this in a previous video. And letter T is time. And this is real time. For instance, if I had something radioactive right now and I waited 3 minutes, the time that would go here will be 3 minutes, starting at time 0. Or if I had something and I waited 50 years, then the time here will be 50 years. And again, it will be in units of seconds, minutes, and hours. Now, before I leave this, I'd like to talk a little bit more about Becquerel and Madame Curie. Here he is. And there's also Madame Curie. Little note here regarding Madame Curie and Becquerel. Awarded the Nobel Prize for Physics jointly with her husband Pierre Curie and Henri Becquerel. This is an interesting statement. Even today, Marie Curie's notebooks of her studies remain too radioactive to handle. You recall the radioactive materials that she was working with were polonium and radium, and they have extremely long half-lives. There is one more I need to mention. In the decay of radioactive materials, there is also X-rays that are emitted, and you will encounter X-rays in your studies later on, and that uses the unit of a Rontgen.